So we're going to look at the chain rule. So if we've got a composite function, y equals f of g of x, if we can differentiate g with respect to x, and we can differentiate f with respect to g of x, then we can find the derivative of our composite function. And what we say is that y dash x equals f dash g of x multiplied by g dash x. Or in Leibniz notation, dy by dx equals dy by du multiplied by du by dx. So you can prove this using your differentiation from first principles. However, we're going to look at a couple of examples. So we want to find the derivative of the function 3x minus 2 to the power of 7. So the first thing we're going to do is we're going to let 3x minus 2 equal u. 3x minus 2 is going to equal u. So that way we can say that f of u is going to equal u to the power of 7, and we can let g of x equal our function inside the bracket, which is 3x minus 2. So now we want to differentiate both of these functions. So we're going to work out the derivative of f with respect to u, and that is 7u to the power of 6. And we're going to say that g dash x, and the 3x becomes 3, and the minus 2 is our constant term, and the derivative of that will be 0. So then we're going to work out the derivative with respect to x of our 3x minus 2 to the power of 7. And we know that that's going to be the derivative of f with respect to u multiplied by the derivative of g with respect to x. And that is our 7u to the power of 6 multiplied by 3. So our next line of working out is going to be that we need to work out this derivative, and we need to substitute back in our value of u. So our value of u was 3x minus 2. So we've got 7 upon 3x minus 2 to the power of 6 multiplied by 3. And then we're going to gather our like terms together. So 7 times 3 is 21. 3x minus 2 to the power of 6. So our derivative of 3x minus 2 to the power of 7 is 21 upon 3x minus 2 to the power of 6. So we need to be able to determine that sine x differentiates to cos x and cos x differentiates to negative sine x. That's not given to us on our formula sheet at Advanced Higher. But in this example, we want to differentiate cos of 2x squared plus 5x. So we're going to let the function inside of our bracket equal u. So we're going to let the 2x squared plus 5x equal u. And I'm going to use Leibniz notation this time. So I'm going to say that y is going to be cos u. And I'm going to let u equal 2x squared plus 5x. So dy by du is going to give us negative sine u. And du by dx is going to give us 4x plus 5. So my derivative of cos 2x squared plus 5x with respect to x is going to be dy by du multiplied by du by dx. And my dy by du was negative sine u, and I'm multiplying that by 4x plus 5. And then I need to substitute in Let's write my function again. I need to substitute in my 2x squared plus 5x in place of the u, so it's going to be negative sine of 2x squared plus 5x multiplied by 4x plus 5, and then I'm going to write minus 4x plus 5 in a bracket sine 2x squared plus 5x as my final answer.